Hello, my name is Steve Phillips, and today we're going to be talking about an introduction to the Tintri VMstore product. So the VMstore product is part of a family of products from Tintri. There's also the IntelliFlash and ExentaStore products, but today we're going to be focusing on the VMstore as part of our intelligent infrastructure portfolio. So first of all, what is intelligent infrastructure? So Gartner defines intelligent infrastructure as it optimizes infrastructure resources for application consumption through the use of infrastructure, machine learning, and applying tuning as software overlays. They add that by 2022, intelligent infrastructure will add infrastructure, machine learning, analytics, and artificial intelligence for IT operations, otherwise known as AI ops in their parlance, as software overlays on top of hardware-based composable integrated systems. Now that's a lot of language there, but in truth, a little spoiler alert, Tintri has been doing this exact thing since 2011. So some of the things that Gartner is saying are going to be very prevalent by 2022. By then, the Tintri approach will have been validated for about 11 years. So why choose intelligent infrastructure? So if it boils down to a couple of points, the first is that infrastructure is growing, but the number of humans to manage it is not. And our customers, thousands of them, have refocused the administrative effort of those admins, of those humans, into enhanced service delivery of those operations, some by up to 95%. So to show it kind of graphically, infrastructure is growing at a, not quite an exponential rate, but a very sloped linear rate. But people and budgets are flat, if not moving downward. So the demand for resources is definitely outpacing the supply of the skilled IT staff required to manage those resources. So there are a couple of ways you can approach that. You can hire more people, which usually means you need more budget, which is usually not going to happen. You can write some rule-based automation to help to bridge that gap, but those rules need to be maintained by human beings and they need to be adjusted based on different changing conditions. And so that's really not a very scalable way to go about solving this problem. So what Gartner says, and we tend to agree at Tintri, is that to bridge that gap, you need a layer of AI ops and intelligent infrastructure. And that's what I'm about to describe to you in terms of the VMstore. So getting a little bit more tactical on exactly what VMstore does is VMstore is a storage product that sits inside of a virtualization estate. When Tintri was first created, it was a storage device that was designed specifically to host virtual machines. And so there are several parallels to this in the virtualization estate. The first is the concept of DRS, for example. You have a layer of host CPU and host memory, and an admin typically is not going to have to determine where those workloads should run. You have software behind the scenes that will make those choices in an automated way for you. So that provides a very high level of automation and a very low touch experience for the administrator. So in a sense, what Tintri's goal was to do is to take that same approach on the host side and apply it to the storage side. So essentially, traditional devices that are applied to the virtualization estate typically have to be tuned very frequently. So as workloads change, you have to either do birds of a feather, where you stick all the retuned VMs together, all the right-tuned VMs together, and the mixed VMs together, and have to maintain that. Typically, you have to have human beings do that. But the best approach would be to have that all be automated. And the virtualization estate as it stands doesn't really provide those types of tools. The only way to really do that is to provide an intelligent layer that sits above the data stores that is able to determine where those workloads should lie. And there are some reasons why, and we'll go through those one at a time. But essentially, the data store should really look the same as all of the other pieces within the estate. So there should be a resource that is finite, but there should be some software that overlays that to determine how to best use that resource in an automated way without human beings having to get involved. And that's precisely what intelligent infrastructure means in the Tintri context. So what does a Tintri do in its core? So what Tintri does, it was designed from the ground up, as I mentioned, to service virtual machine workloads. And so virtual machines are a little bit unique in that they share a data store, they share a shared resource within the virtualization estate, but they can act very, very differently from each other. And as I mentioned earlier, that's why you tend to put VMs that run the same way in the same data store. But unfortunately, virtualization is really not controllable in that way. You may have users that change the way they behave. You may have applications that change the way they behave. And so what we decided to do from the very beginning is allow us to understand what a VM is and be able to track how that VM behaves and what types of requirements that it has for those applications. And the only way to do that is to understand what a VM is. So a virtual machine is really just a collection of files. It can be virtual machine disk files, it's some metadata, et cetera. So from the very beginning, we designed our underlying file system to understand virtual machines as the files that they are. So typically it's a very small amount of very large files, unlike a general purpose file system, which is designed to support a large number of very small files. And so we also decided to create queuing at the individual file level. So what does that mean? So on the left-hand side, you see here, the typical queuing system for a data store kind of looks like a funnel. You have a lot of different types of applications and workloads writing into the top of this funnel. And the storage device sits on the bottom, and it starts to see things in serial, one at a time from these workloads. And it's going to react to those workloads to the best of its ability. But it has no idea what's coming down from the top of the funnel. It doesn't have visibility to that. And this is very common with block-based protocols like iSCSI and Fibre Channel, where you have information coming down these queues, but the data store itself has absolutely no idea what those workloads are. It just knows how much is flowing down the pipe, and it tries to keep up the best that it can. On the right-hand side, however, we've taken a completely different approach. We've allowed each individual virtual machine and each individual virtual disk to have its own queue. And that queue can then be changed in terms of its depth based on the requirements that that workload has. Now, if we have enough resources to service all of those virtual machines in the queue, then we probably don't have to make any decisions. We just allow things to work as normal. But in this case, you might have a SQL server that at the end of the month does a reporting cycle. And so that SQL server at that particular point in time may ask for 1 million IOPS where there are only 200,000 IOPS available. So in the left-hand example, where you just have a funnel sending down a whole bunch of data to the data store, in that case, that SQL server will start to push out all the other workloads around it. And so the other workloads besides SQL will start to suffer. So they don't understand what's happening because the data store really has no way to react to it. All it knows that it's becoming very busy. And in some extreme cases, those workloads can actually be starved out completely. And in some cases, even crash, shut down, et cetera. So the advantage of doing a per VM queue and a per vdisk queue is the ability of a Tintri device to manage the depth of that queue on a per VM basis. And so we would give that SQL server enough performance where it's going to be able to satisfy the vast majority of its requirements, but we won't give it too much. In other words, we're still going to have a fair share scheduling system underneath that's automated that will allow those other virtual machines that are surrounding it, its neighbors, if you will, the ability to get data. So those virtual machines don't even notice that SQL Server has changed its behavior radically. We manage that in a very automated way. I'll show you some manual examples of how that can be controlled if necessary. There are some specific use cases for that. But in general, this is how it works. And so being able to be aware of a virtual machine, because we use a file-based protocol, we use NFS and SMB3, we're able to then understand at a very deep level what those virtual machines are and then be able to change our behavior in an automated way accordingly. So what does that mean? So at the end of the day, we've taken that same approach on a per VM basis. And because we've purpose-built the file system for them, we can then apply additional features and functionality to those VMs. For example, we can start to use data management functions like being able to restore virtual machines to previous states, be able to take snapshots of them at the array level, being able to replicate those to another location. It opens up a whole world of possibilities that we can provide now that we're performing things at the correct level of granularity, which in this case is a virtual machine. And we also publish a very rich API. So if a customer or a user wants to do all their own automation, we make it very, very easy for that to happen. And then we also do intelligent scale out to match whatever growth possibilities you may have. In the same way that you would add CPU and memory into a DRS cluster, we feel that it should be the same for storage. So we offer what we call Tintri Global Center Advanced. which has a pooling feature that will monitor not just capacity, but also raw performance and also working sets. So how much of that data is actually being used, and then make recommendations twice a day to determine where those should be placed. So for example, if you have hybrid systems and all flash array systems, we can determine which workloads should sit where, and then optionally even do the migrations for you to make sure that you're in an optimal state. So with that, let's start with the demo of the product. So here is a example of a Tintri VMstore that has a very, very large amount of workload attached to it. This machine is very, very busy, and we have a number of synthetic and a few real workloads that are running on this particular system. So we give you a overview here of how many IOPS are flowing in and out of the system in terms of what's happening right now, and also the 7-day range using 10-minute averages. So you can see exactly what's going on from a 7-day historical perspective. We do the same for throughput as well. So as you can see here, we're throwing a lot at this box. But you also see over here on the right that there's a couple of numbers for latency. So the first number is a little bit elevated because we're really stressing this box very hard. The typical latency for an all-flash array like this one is well under a millisecond. But you see here, there's a couple of different things that are happening here. The first is we're showing you the latency as it's actually being seen from the array level. But you also see there's a few colors underneath that, and then a second number. So that second number shows what the actual experience of the virtual machine is in this particular environment. Now, what is the difference between those two? Well, if I hover over that little bar there, it shows me exactly where that latency occurs. So as I mentioned earlier, because we have very tight integration with the hypervisor management framework, in this case, we're going to use vCenter and vSphere terminology. Because we're speaking to vCenter and gathering data about the VM's experience, we can then start to break down exactly where the latency occurs. So instead of a lot of guesswork, you can be very exacting in terms of troubleshooting a virtual machine, maybe seeing what the user may consider slow performance. So it may come from the host side, so then they'd be queuing at the host level, which is labeled as green. It may come from the network side, which is labeled as yellow, and I'll have an example of that here in a moment. And it may come from the storage side. So if the storage side is stressed, you may see slightly elevated latency on the storage side, and we'll be able to determine that as well. So let's take a look at one particular virtual machine here. And this one is a machine that is seeing slow storage performance. So let's click on the metrics tab here. And what we're going to show is we're going to show exactly what's going on with this VM from a couple of different angles. So in this case, I've got a couple of different metrics here. I've got IOPS, and we can actually select normalized IOPS as well. So normalized IOPS will normalize any IOP to 8K. And this is important when you're starting to compare one workload to another. You want to make sure that every IOP is not created equal and it's not reported on equally. So we can actually do that normalization for you. In this case, we want to see exactly how this is performing from both an IOPS perspective and from a latency perspective. You'll notice here that even though this virtual machine is seeing latency up around the 20 millisecond range, actually 24.5 at the peak, that there's a pattern here. So the pattern that we have in this particular VM is that we're running this through a packet shaper that changes the network behavior over time. And as you can see here in this 1-day chart, you can see how that is changing. And so at any given time, I can tell, well, it was 7 milliseconds here, and it was 23 milliseconds here. And you notice that the virtual machine itself is reporting latency that correlates to that particular amount of latency that's happening at the network side. So what I've done here is I've shown that the host is actually not struggling at all, but the network is actually the bottleneck here. And so this is something that would be typical in an environment where you have a VLAN misconfigured, or the storage network is actually taking an extra hop, potentially northbound from a UCS, for example, where it shouldn't be. And so there's additional latency where that maybe shouldn't exist if it has been configured correctly. So in this case, you might want to look at the configuration of the host networking itself to make sure that it's clean. But again, this has nothing to do with the actual performance of the virtual machine from either an operating system standpoint or from the configuration of that VM, or even the host, at least the vNICs, just may be configured incorrectly from a virtual switch point of view, where it's pointing it down the wrong path, or it could be at the switch layer. So it gives you a pointer of where you might look to find the problem. Let's move on to another example of what the Tintri can provide in terms of not just reporting capabilities, but in terms of the actual control of that particular VM's behavior. So in this case, I've got a VM which is much busier than the previous VM. This one is running at about 50,000 normalized IOPS. The latency here on this side is in the 6.5 millisecond ballpark. And again, this particular array in our demo lab is being hit from all sides. So don't get too caught up in the absolute numbers themselves. But what I'm going to show you here is the ability to track how a VM is going to behave differently when we change the QoS settings on that VM. And on the right-hand side here, if you notice here, if I zoom into an hour, you'll notice that here I'm now taking much more granular samples of this virtual machine. These are all on 10-minute samples. But on the right-hand side of this real-time chart, now I'm taking real-time samples. And we do that to make sure that we're not spamming vCenter, asking for very granular data about more than one VM at a time, because that would cause an inordinate amount of traffic if we were doing it for thousands of VMs. So we're trying to save vCenter from getting completely overwhelmed. So in this case now, we're able to see this traffic is pretty consistent. Truth be told, this is a synthetic load generator. So what we're going to do is we're going to go to the settings tab for this particular virtual machine. And you notice here at the bottom, we have the ability at the top here to create a snapshot schedule, and we'll go into that in a little bit. We also can replicate to another VM or the cloud. But in this case, we're going to focus on quality of service. So right now, this virtual machine does not have a limitation on the number of normalized IOPS that we're allowing. So in this case, what we're going to do is it's running about 50,000 today. What we're going to do is we're going to limit it to about 10,000, and we're going to click Save. So when I click Save, I'm going to click back to this other window over here, and we're going to watch the real-time chart change for this particular VM. So again, every 10 seconds, we're going to take a new sample. So over that 10-second sample, it's gone down to 34,000 normalized IOPS, and we'll wait for the next iteration to occur. And now we're down much lower. We're actually down to 10,000. So this virtual machine is now consuming as many IOPS as it can possibly consume. And the way that we've done that is we've modified the queue depth for that particular virtual machine and that virtual machine only. The other VMs don't notice this is happening. We've done this on a per VM basis for this particular VM. And you'll notice here at the bottom, the latency is now radically different. So you'll notice that the latency, where it was stable at around 6 milliseconds or so, has now ballooned to about 33. And what's interesting here is we can, because we understand exactly what's going on and why that latency is occurring, we can put it in a bucket called throttling. So throttling means that we are essentially injecting artificial latency into this VM to bring it into line with the limit of the number of IOPS that we're imposing on it. So in this case, it's 10,000. But you'll notice that as soon as it applied that limit, that virtual machine changed its behavior accordingly. Now, in this case, it might be a very latency sensitive application. It may not get the performance that it really wants. But the important thing is now you can fit it in with the rest of your environment and set a limit on it. And in some cases, there are some applications that are not bandwidth sensitive or not latency sensitive. So in this case, it may not affect the performance at all. But in this case, we're making it be a nicer neighbor to the people around it. So again, this is a manual process. You don't have to do this. It's just an example of the instant action that setting a QoS limit has. And if we need to take this action for a particular VM, we can do it in an automated way. We'll let you know about it, but we don't make you do it. So one of the things that's interesting here is that if we were to see a virtual machine that in an automated way, we had to change the queue depth on and therefore inject artificial latency to save the experience of other VMs, it would actually show up as a slightly different color. It would show up as a little bit more purple than the throttle color. And we call that contention latency. So in this case, we don't have enough traffic running through this box to create that situation. But if we did, it would show up as purple contention latency. So you can see here now, this is still steady. So we're going to go back and I'm going to re-edit this and I'm going to remove that limitation. I'm actually going to set it back to the way it was. And then I'm going to click Save. And you notice here that the host latency is a little bit different than the throttle latency. The reason why is because we only gather the host data, the actual queuing latency at the host side on a 1-minute sample instead of a 10-second sample. So you may see that jump around a bit based on when we actually make the sample. But you'll notice that the throttle latency has now largely disappeared in the last sample. In fact, it's completely disappeared here at the sample of 52 minutes and 48 seconds. You see here now the VM has returned to its previous state. So now it's running at about 50,000 normalized IOPS. The host latency, once we get to the right sample, will dip down to its normal area, which is around 1 millisecond or so. So this VM is now returned to normal. It's just that the particular sampling that we do for host latency lags a little bit in this real-time chart. So let's talk a little bit more about some of the specific functions that you can do on a virtual machine that might make your life easier. So one of them is based on a virtual machine called S. Phillips Win 2016. So this is a virtual machine that I created that I do some SQL testing on and things of that nature. And what I've done with this particular virtual machine is over time, I have made some changes to that virtual machine, and I've taken some snapshots to capture some of those changes. So one of the more significant ones was in February, I created a snapshot before I upgraded it in place to Windows 2016, and I actually have that VM up and running here in the background. This is before I upgraded it in place to 2016, and then I created a snapshot after I upgraded to 2016. So you'll notice that the virtual machine name changed in between. So after I made the upgrade and before I made this particular snapshot, I actually renamed this VM from Win 2012 R2 to Windows 2016. So what I'm going to do is I'm going to right-click on the name of the VM, and you'll notice here that a vSphere plugin that we offer adds an extra context menu here with some additional actions that you can take on that particular VM. So for example, I can take a snapshot just like you see this list. I can view them. I can take a clone of that virtual machine. In fact, I can create dozens of them if I want to. I can set a schedule for this particular VM, can synchronize the VM, more of that in a second, or I can configure the QoS directly from here. So I don't necessarily have to log in to a Tintri branded tool like Tintri Global Center. I can actually do that straight from here if I want to. But let me focus on the synchronize for a moment. So one of the choices here is called Restore VM. So in this case, what we're going to do is we're going to restore that VM to a previous state. So using the array-based snapshot that I created, I want to restore this VM back to the state that it was on February 2nd. So when I do that, we're going to do three things. We're going to issue an API to vCenter that will ask vCenter to power off this VM. The next thing we will do is we will restore the folder that contains the files for that virtual machine. We're going to do an in-memory file system operation and revert that back to that previous state from that snapshot. So there's no data movement. And then third, we're going to reissue that same API command to vCenter to power it back on with the VMs in the previous state. So I'm going to click Restore, and you'll notice the tasks happening here. So we've already powered it off, and you'll notice here that we're doing some work in the background, the sync restore VM task, and we're going to power it back on again. So the function is already completed, and when this thing boots up again, it's going to be booting up, and you notice that the machine name has changed to Win 2012 R2. So it's exactly the way it was back on February 2nd. And when that machine boots up, it's going to be running Windows 2012 R2. And this machine is available for use. So as you can see here, it's running 2012 R2 standard. So now you're back to running Windows Server 2012 R2. Everything looks great. You're up and running. But what if this was the wrong VM? So this is great for recovering from ransomware, things of that nature, be able to get out a jail-free card without having to use backup infrastructure and have to move data around. This is obviously a great tool. But what if you picked the wrong VM? So we built in some job security where if you pick the wrong VM, we give you a get out of jail free card for that as well. So let me refresh the list of snapshots for this particular VM. You notice that one of them popped up here right at the top. So this one here, we call it a safety snapshot. So before we go back in time, we actually create a snapshot for you so you don't forget. And we can use that to recover if we happen to pick the wrong virtual machine to recover. So in this case, I'm going to go back here. I'm going to click Restore VM. This time I'm going to pick the safety snapshot, which happened right when I went back in time. I'm going to click restore, and we're basically going to do the same operation in reverse. So we've powered off that virtual machine. We're going to do the in-memory operation in the file system to recover the data per its original state as of about 3 minutes ago in real time. And then we're going to go ahead and issue that power on command. You'll notice that vSphere has recognized that that machine name has changed back. Notice that the UUID of this VM does not change. So if you have applications that require some sort of hardware check that's typically based on a hardware UUID, that does not change. So we're not creating a clone of this particular VM. We're actually recovering it in place. So you don't have to go through either Windows activation or other things. That'll be clean going back and forth. And now I'm back to running 2016 again. So again, this is a very quick way to not just revert in case of a disaster, but you may have a use case where you need to return a virtual machine to a previous state many, many times. So for example, if you're running test dev or QA and you need this VM to be back into a known good state, this is a great way to do it. So let's talk a little bit more about some of the additional automation that Tintri Global Center provides. Or one example is service groups. So in this case, I have a service group that has a specific membership criteria. So there's rules of membership for each of these service groups. Think of these as policies. So in this case, this particular membership is based on my name. So anything with this string, any virtual machine in my environment, my Tintri environment, with this particular string in it, is going to meet the rules for this particular virtual machine. And what I've decided to do here is apply a certain set of criteria to it. So I want to be able to protect it a certain way. So I want to be able to keep hourly snapshots. I want them to be taken at 5 minutes after the hour. And I want to take daily snapshots as well. And it gives you different retention policies for each. But you notice over here, there's two different types of snapshots. One is a crash consistent snapshot, just like I pulled the plug on a physical server. There's no data integrity checking. There's no flushing of data in flight, anything like that. But in this case, I might want to take a daily snapshot that does do those things. So in this case, what we'll do is we'll leverage a hypervisor snapshot, in this case, vSphere. We'll take a vSphere snapshot first. That will allow VSS tools or guest tools to be able to flush the data in flight or potentially even run custom scripts within that virtual machine to quiesce databases. We'll then take our snapshot once we've got notification that snapshot is complete. And then once that's done, we'll remove the hypervisor snapshot. So you don't have any of those laying around, which can cause performance problems. But we can still leverage what those are good for, which is making sure that data is consistent. So in a case of a database server, this would be really handy for recovery purposes. You can go back to 2:30 in the morning the previous day, and then roll your logs forward and make sure that you could recover without having to do a whole bunch of integrity checking, even on a very large database. And then at the bottom here, we can also apply QoS rules. You can replicate to either another VM store somewhere in your environment, or you can replicate to anything that speaks S3. So whether it be Amazon's S3, IBM CleverSafe, or maybe something that speaks the S3 protocol, you can define a replication path for that data as well for long-term retention of snapshots, for example. And then again, here you've got QoS. So you can set limits or reservations for specific types of workloads. And this is typically used in the cloud service provider space where they might want to sell you more performance for more money. So they can set up their own API, if you will, to say, hey, if I click this button on the portal, the customer portal, that VM will instantly get more performance. So there's a way to monetize that in the cloud service provider space. We have cloud service providers doing this today. So let's move on to our pools feature. Our pools feature is what I mentioned earlier around being able to do an intelligent scale out of your workload in a similar way to how DRS will help make decisions for you and then suggest how those decisions might optimize your environment. So in this case, we have a mixed pool in our production demo lab, and that mixed pool contains a number of VM stores, one of which is a hybrid and the others are all flash arrays. So one thing you'll notice here is that every day, twice a day, once at daytime and once at night, it'll offer a series of recommendations based on issues that are being experienced. So in this case, the hybrid array that is in this environment is experiencing heavy load. What does that mean? So if I click on view details, it spends about 14% of its time under what we call heavy load. So we may have to start making decisions around how to apply resources. And in those cases, you may see higher I/O latency. Now, what happens to this VM if we decide to follow these recommendations? So for example, here, we're suggesting that one particular virtual machine gets migrated. And if I click on this VM, it'll show me exactly which one it is. We're suggesting that that get migrated from this source to this destination. Okay, well, that's great. But what would that do to my environment? So you'll see here on the outcomes pane, it'll show you both good and bad what will happen if I follow these recommendations. And we do a lot of regression analysis and forward-looking analysis to make sure that we're not ping-ponging VMs across the environment. We want to make sure that once we put something somewhere, it's probably going to stay there, assuming that things stay somewhat static. We understand that things are very dynamic. We also try to track those types of patterns. Once we suggest that you move something from one VM store to another, it's probably going to stay there, and we'll show you why. So in this example, this one will experience heavy load less than 8% of the week. So it went from about 14 to about 8. So that's good. Space usage will go down on a couple of different units, but space usage will go up on some of the targets. So we'll let you know both good and bad what's happening. On the whole, there are 6 greens and 2 reds. So I would say that's a good optimization iteration. And if you click execute, we actually do all of the API calls for you to kick off the migration process. And what's unique about using Tintri's migration is we offload it from the hosts themselves. So essentially what we do is we issue a storage vMotion API command to vCenter, but we specify a very specific flag for that process to say we are going to take care of the copy. So vSphere don't do the copy. And the copy of vSphere is quite inefficient. It will go in and copy all the zeros if there's white space on that VM, number one. But number two, it also uses the host to do the copy. So it's using a full pipe potentially for read and a full pipe potentially for writes. And so that can jam up the performance of VMs that are currently doing their normal work. What we do is we use our replication technology to go directly from Tintri to Tintri using the data network or potentially a separate replication network to migrate that data for you. And we already have the data deduped and compressed before we start sending that data over. So it's an extremely efficient methodology for moving that data from VMstore A to VMstore B. And then second, we also migrate the array-based snapshots of that virtual machine. So if the admins have a SLA with their customers, as far as data protection goes, in a typical storage vMotion, those VMs snapshots would be orphaned on the source, and they would not make it to the destination. If you use this migration function, we actually do that for you and make sure all those snapshots get migrated to the new machine. So this is an optional tool. You can do these on your own if you like, but we feel like there's enough value where pressing that execute button will get you to a better state in this case. So let's move on to the analytics platform. So Tintri provides a very, very rich cloud-based analytics platform that you see here on your screen. And what this provides you is a view into not only what's happening in your current environment, but also gives you some planning tools to figure out what-if scenarios. So let's look at a couple of different examples. So in this case, you have a very simple pie chart, if you will, of how much space you're using versus how much total. I/O performance. This is in terms of what we call performance units, which are roughly analogous to an IOP, but those IOPs may not be the same between hybrids and all flash arrays. So we've done some weighting to make sure those are normalized to the best of their ability. And we also look at working set as well. So how much data is actually being accessed versus how much is in there in total. We can also trend this data over time to say, here's what we've looked like over the last 3 years of data. So this is where the capabilities of analytics start to diverge from where Tintri Global Center might give you 30 days of data or the VMstore might give you 7 days of data. This gives you 3 years. And so in this case, I might want to know, well, what happened on this particular day? There was a spike in performance. So we give you the ability to drill down into any point on this chart to find out exactly what was happening. So in this case, this was September 16th. And I can see by clicking which were my largest contributors on this particular day. So on this day, this particular VM was consuming about 60,000 units of performance, and that was very, very large. So if I step back one day, You see that spike was still going on this day too. So again, because I see 3 years of data there, the granularity was such where that spike probably lasted a couple of days. So I can look through all of these and see, well, are any of these something I didn't expect? I can also change the view and say, well, show me my biggest consumers of space. So I've got a couple here, it's the same one actually, that are using a very large amount of space. Again, that might not be something you expected. And so you can go in and determine on that particular day what might have been happening that either caused an issue or the administrators were asking questions about, or your customers were asking questions about. We keep all of this data for 3 years, so you can go back and figure out what might have been happening on any given day over that 3-year period. We also here show you infrastructure data. So some of the data that we gather from vCenter has to do with the hosts themselves. And so one example might be how much memory is being consumed and how much CPU is being consumed. And if I want to find out here which ones of my virtual machines are using the most CPU, I can do the same. And this one happens to be our Zen server. So this one is using a tremendous amount of CPU. Again, that may not be expected. So if you're trying to find the outlier, if you're having performance problems, it makes it very easy to do so. Another Zen server is also using 7.3 gigahertz or so, 7.4. So this one is very, very busy as well. So apparently we might have been doing some desktop testing, some load generation based on Zen desktop or Zen server. And so these guys are really, really busy. We do the same for memory as well. So memory outlier happens to be, in this case, VROPS. So VROPS is using a ton of memory. We might have been running some tests on here too. Again, maybe it's interesting, maybe it isn't. But in this case, you can find out who those outliers are. vCenter is using about 6 gigs. We have a couple of different ones. TGC is using 5. And then we've got a particular user who's using a ton of memory on his desktop. So again, you can find out who the heavy users are just based by drilling down into that particular chart. There's a couple of extra panes here that are interesting. One is this shows you what the average VM looks like of those that are powered on. So in this case, I've got roughly 640 or so. And it shows you what that typical VM looks like. But also here at the bottom, what you see is we've defined some what are called applications. So these applications can be really useful to determining what might happen in a future case. So for example, here, let me go to the application definition. So in this case, I've got one defined that are called Steve's Lab SQL servers. And if I edit the definition of that particular one, you'll see here, any VM that's in this environment that contains the name SQL in it anywhere, not just the beginning or the end of the string, but anywhere in the name, I've added it to the list. Or I could say, for example, I want to add any VM that's under a specific folder. And because, again, we're very tightly integrated with the hypervisor management framework, I understand what the folder structure looks like because I query vCenter. And it doesn't matter what hypervisor you use. I'm using vCenter terminology. But in this case here, I can see all of my folders that are in that vCenter server. So in this case, I might say anything in my production lab, or I might drill down a little farther and say any lab users folder, and I happen to have one in here. So anyone that happens to be in this folder should also be included in that, right? Or I can trash it. So again, I go back to these 38 matching VMs. So now that I've defined that, what is interesting about them? Well, now I've got these 38 VMs. Well, this is what they look like. So typically they'll consume about 50 gigs of space, and I can view the distribution if I like. And these tend to be very quiet. So in this case, they're not using any performance. They don't really run any working set. These are used fairly infrequently, but you can get an idea for what they're used for. Now, why is that important? So if I go to this particular chart, I may need to plan for future growth. So one thing I can do very easily is filter this based on one specific VM store. So in this case, I'm focusing on this EC6070 that's in our lab that you can see is extremely busy, as I've shown in the previous dashboards and so forth. So it's very busy. It's getting a little bit more workload as time goes on. But as you can see here, it's kind of in the danger zone in terms of performance, where it might have to start making decisions about resources that are available. So one of the questions you may have is, well, what do we do about that? Or if changes are made, what might happen? So there's a link right here for plan for future growth. And what that does is that takes the current state of affairs and it pushes the chart out about a year or so to say, okay, how is this going to look over time? So you see the space is growing at a certain rate. If I want to edit those rates, I can do that. But it's also growing at both physical space and also a little bit in terms of performance. I can also limit the amount of time that I'm making these calculations on to maybe the last month. And if I took it the last month, now I've really got some serious issues because I've been adding a lot of workloads into this environment pretty recently. So under the new action tab, what I can do is say, okay, I have a new request that came in that said, hey, by the way, those SQL servers that we talked about, I'm going to add some more of those VMs in there, and they're coming on April 1st. So if I click continue, it gives me the choice to say I can either add an average VM across the whole set of VMs that are on that system, or I can pick a specific definition and say, okay, these are the ones that are going to be added. So they're very quiet, but they do add a lot of space. So for example, if I added 100 of them, you would see here, it would move the needle a little bit in terms of space, but not in terms of performance. So I'm still a little bit over the limit on performance. So I might want to do something about that before these particular workloads come into being. So I can also add, in this case, I can add a VM store. So in this case, I might need to add some more resources to this environment, and I might want to add them fairly soon. So let's pick March 20th. And I can pick in here what kind of model that I might need. So let's say we choose a 6090. What would happen if I added a, for example, a half populated 6090? We're not so constrained on space. So maybe I change the drive size to something a little smaller, because what I'm looking for is really performance. So I've taken that performance curve that is going up to above a 95% or so, and I'm dropping it almost immediately down to about 40% or so. So you can see here, that's bought me roughly about 6 months, assuming that the growth rate remains the same. Now I know exactly what I need to put in this environment in order to meet that particular need before it comes up. So this is a very handy tool for going and justifying a new purchase of a resource. So in the same way that you would do it if you're short on memory or short on CPU, you would add them into an environment, you would set up DRS, you would have DRS load balance the workload. We feel that that approach should be exactly the same for storage, and that's why these tools are available to you. The other thing I do want to show is the ability to deploy what are called common VMs. So one of the nice things about having the granularity that we do is we've been getting 10-minute performance samples of a very wide variety of virtual machines since we started in the year 2011. And so we have a ton of data that we can draw from to determine what a typical VM might look like. And so we've anonymized that data and then made some determinations about what a typical VM might look like under certain conditions. So for example, here, if I have another set of VMs that's coming in, let's say on May 1st, and I click continue, it'll ask me what type of VM is that? And we give some examples here. So these are some categories that we've created, and we use actual real data to determine what the typical size of these VMs are. So for example, here, I'm adding some large SQL servers. So I click on that, and it puts in the values that are correct for the average large SQL server that we found in our analysis. So let's say, for example, here, I'm going to be adding 10 of them. Well, if I add 10 of them on May 1st, the question you may have is, do I have enough resources to handle those specific applications? And in this case, I do. But if I change that number where maybe it's 50, now I have different decisions to make. So now, instead of being out of performance, now I'm out of space, because these typically tend to be very large. So these are 2.5 terabytes in size. So I may go back to my initial configuration here and make this machine fully populated, and I may actually use larger drives. So I can choose exactly what the optimal configuration is based on my choices of the type of system and then the types of drives that are in that system to optimize where I want to end up after these additional workloads have been added. And I can also optimize based on how much runway I need for a 2-year depreciation cycle or a 4-year depreciation cycle, whatever you might be running on. So if I add 2 of those systems in, now you see my runway is out to November. If I add 3 of them, it's probably going to be out much further than that, and you can go out a couple of years on this chart. Now I'm not crossing that threshold until May of next year. And again, as you've noticed here, we've already run all of this analysis in the background. So when you make these choices, we already know what the right answer is. And so you're not waiting for it to be calculated. And again, this is something that's running in EC2. So when we update this tool, it's not something you need to go and change. So we can do it in the background for you. You log out, you log back in, and there are new functions and features available in this tool. The other thing that's also present here, and there are no examples of it in this case, but we can see here that in this case, we have some activities, call them activities, that are popping up on this right-hand side. And what will show up here are things like if your VM store is not sending data, dial home data back to us. That might be one example of an alert that might pop up here. Another one might be that we've detected a signature for a specific workload that might be causing problems. So for example, seeing very high host latency, and we've determined that a certain signature of performance might determine that that particular VM might be over provisioned in terms of virtual CPUs, which causes a certain type of latency. And so therefore we can alert you to say, you know what, we've noticed this signature here that a virtual machine is running with 24 virtual CPUs, and that particular host only has 16, for example. So that would probably cause a lot of queuing on the host side. And so we can bring that to your attention via this particular tab. So you will see this filled in over time with not just basic storage alerts and things of that nature, but also things that are specific to the virtualization environment, things like vCPU over provisioning, things of that nature. So with that, I did want to bring up the current platforms that we offer. And as you can see here, there are 4 different platforms, one of which is the 6030. All of these are all flash. They go to the mid-range, the 6055, the 6075, and then the 6090. So you'll notice in the rows underneath it, it shows you roughly the number of VMs, not a hard limit, but it's a rule of thumb of how many they can support without causing any kind of performance degradation. We also show you IOPS. Those are at 8K at 1 millisecond. And then the usable capacity versus effective capacity. So all of these machines do dedupe and compression in line, so it's not a post-process. And we typically use about a 3x number for dedupe times compression. Your numbers may vary, but in a general sense, this is a good rule of thumb. Some environments like virtual desktops can be very, very high, up to 7, 8, 9, 10x. But for server workloads, for other types of applications, 3x is a pretty good guess. So depending on the size of drives you pick and the amount of performance you need, can help you get to the exact configuration of the machine that makes sense for you. So to summarize, we talked a lot about the VM store. There are also additional products in our portfolio, IntelliFlash and ExentaStore, that can provide block-based storage and NVMe storage, and ExentaStore for file service workloads. So a full range of workloads and use cases, but most importantly, the addition of intelligence into your infrastructure is really where the market is heading, and it's heading there very, very quickly. We've been doing that for a very, very long time with a lot of different customers, driving business results, using tools like automated QoS, as I showed, using real-time and predictive analytics to help you make decisions, and providing a whole range of data insights to help meet your business goals based on your actual performance. So we thank you for watching this video. If you would like more information about Tintri products, please go to our website, tintri.com, or give us a call at 1-855-4-TINTRI.